In this problem, we're asked to use the limit definition to find the derivative of the function. And if you haven't studied derivatives yet, it just means to evaluate the difference quotient, which is a limit. It will connect that to derivatives later on in the class, but for now, let's just practice with a limit that generally results in a function rather than a single point. So, for instance, what I need to evaluate is f of x plus h. That's a great place to begin. So if I just take my function f of x, think of it as whatever I put in parentheses as an empty box. So I just replace all my x's with an empty box. And if I put x plus h inside those parentheses, then automatically x plus h shows up everywhere there was an x in the original function. So f of x plus h is 5 over x plus h. F of x is, of course, just 5 over x. Now, in the numerator, what we're looking for is f of x plus h minus f of x. So that would be 5 over x plus h minus 5 over x. This can be combined into a single fraction to simplify, but we would need a common denominator. So I would need to multiply the second fraction by x plus h over itself, and the first fraction by x over itself, so that my common denominator is the quantity x times x plus h. So this would be x times x plus h in the denominator. Then 5x would come from this first term, minus 5 times the quantity x plus h. We would need to simplify this as much as possible. So let's see what happens if I distribute the negative 5. So 5x minus 5h all over x times x plus h. These 5x's cancel each other out, and that leaves me with negative 5h over x times x plus h. Now, that gives me the numerator, so this f of x plus h minus f of x. I then need to divide all of that by the denominator, which is h. So f of x plus h minus f of x divided by h. That would be negative 5h over x times x plus h divided by h. This gives me a compound fraction, and I can change this h in the denominator to h over 1, just making a fraction out of a whole number. And that allows me to invert and multiply. So negative 5h over x times x plus h times 1 over h. Now this h in the numerator and denominator can cancel out, leaving me with negative 5 over x times x plus h. The last thing I need to do is take a limit as h goes to 0. So the limit as h goes to 0 of f of x plus h minus f of x divided by h is the limit as h goes to 0 of this simplified object that I just came up with. And when h goes to 0, then this becomes negative 5 over x times x plus 0, which is negative 5 over x squared.